have 3 things to share with you today about planes and lines. So, the first thing first is that the type of questions, exam questions that exam would typically ask, I don't know, but for me, I do encounter, is that does this vector lines on the plane? Actually, I forgot to put the arrow over here, yeah. So how do you prove that is this vector on the plane? How do you freaking prove it? Okay. And then, okay, just assume that we have some point A. Okay, I call it 3, 2, 1. Right, this is some point. So I have this vector over here. So how do you prove that this vector is on the plane? So if you were to visualize, the plane itself is some point A. Okay, since I've already given to you, this is given. Okay. I think I just zoom out a little so at least we can see clearer. I don't know whether is it too small for you, but yeah. So I have some point A and then some point B and then some point C. Alright, so they're trying to ask, is this vector, this orange color vector, lines on this plane? Okay, lines on this plane that is set up by AB and AC. So this is generally the meaning of it. So the first thing you're gonna do when you see this type of question is to sub in. Okay, you know that the coefficients 12, minus 6 and 8 are normal vector. I've said it in the previous video. If you don't remember, or you don't, or if you are new to this video, the coefficient 12, minus 6 and 8, in this case, this is the equation of the plane. Okay, this is the equation of the plane. So the coefficients of this x, y and z is simply the normal vector of the plane, which is somewhat normal to the vector AB and the normal to vector AC. That's the meaning of the normal vector itself. Alright, so if I take this vector 0, minus 8, minus 6, if I multiply with this normal vector, okay, so I dot product, I wouldn't call it multiply. And please remember that it's a vector dot product with a vector, because it's a normal vector and this is a vector, then you can do that. If you do, please don't do points. Okay, don't take 3, 2, 1 and then you dot product, because you're talking about point. We want vector. Okay, so 12 times 0, I have 0, plus minus 6 times minus 8, I have plus 48. 8 times minus 6, I have minus 48, equals to 0. Dot products is equals to 0 means that they are perpendicular to each other. And here we could see, we can therefore prove that this vector is perpendicular to the normal vector. And then, how do you prove that it is on the plane itself? How do you freaking prove that it is on the plane itself? Right? So we know that one point could simply be connected to A, right? Because this is just some vector. So we can place this vector onto A, and this is simply on the plane itself, right? Or nonetheless, if they ask you if it's this point, okay, hold on a while. Now let's take a look in another scenario, okay, Okay, previously we were talking about that scenario just now, but now somewhat a little twisted story. What if they ask you that is this point on the plane? Okay, this point P. So P is equals to 3 minus 6 minus 5. Alright, so you can sub in this point into this equation. If it's equals to 2, then this means that this point is on the plane. So if I sub in 3, 12 times 3, and then minus 6 times 6 plus 8 minus 5. Okay, I just simply sub in x, y, z only, okay? I will have here 36 minus 36 and plus minus 40. In this case, this is equals to minus 40. Okay, so therefore it's not equals to 2, and we can conclude that this point is not on the plane. Okay, actually I want to make it on the plane, but So the meaning is that if it's equals to 2, then it is. But anyway, down, what the hell? Okay, but generally, if let's say P, it's, maybe I should go and find it. Hold on now. Never mind. I don't change the equation. I mean, I don't change the point. I just change the values over here, and that's it. Okay, just bear with me, or yeah, I apologize to you because this is my mistakes. But generally my approach is to prove to you that if let's say I sub in P is equals to 3 minus 6 minus 5 into this equation, okay, which is what I did earlier just recently now, I have equals to minus 40, which is equals to this one. Then I can say that point P is on the plane itself. Alright, so point P minus A will have 0, minus 8, minus 6. Okay, so for example, if I take, because I have point A over here, so if I take 3, 2, 1 in this case, so 3 minus 3 is equals to 0, minus 6 minus 2 is minus 8, minus 5 minus 1 is equals to minus 6. Okay, so I'm taking this minus this, this minus this, and this minus this. That's what I'm doing right now, right? And therefore, since A is already on this point, P is also on this point, this means that this whole line is like this plane itself already. And then if you want to furthermore do it, you can take P minus A. P minus A is equals to some vector, and which is the vector over here, but yeah, anyway, so you just sub these vectors back into the dot product system, and then you just calculate. If it's equals to 0, then yeah, bam. So you need to do two things if you're talking about the points. You need to first find to sub in the points into this equation. If it's equals to whatever values over here, then this means that your point is on the plane. Next, find the vector. So I just write it down so at least you can visually download it inside. So the first thing you need to do is to sub in points in the equation. I'll just say equation of plane. So this dude over here is the equation of plane. Next, prove dot product of the vectors. Okay, vectors. Okay, yes, that's equals to 0. Alright, with the normal vector, which is what I think you have just know what I mean. Anyway, and this is the thing to prove that either a point or the vector is on the plane. So this is the one of the key test paper questions that they usually ask. The next thing is something a little special. The next scenario is, let's say I have 3D plane now. I have X, I have Y, I have Z, and then they have this little triangle plane that lies. There's this tip hits onto the ZX, position plane, and then its base is lying on the XY plane. Okay, so they actually give you some equation like 5x plus 2y plus z is equals to 10. Okay, so this equation of the plane is being described over here. Alright, this equation of this this chip, this potato chip, anyway. And therefore, to find, they want you to find the equation of a line that touches x and y. Okay, or similar things are like, they ask you to find this line. Okay, they name this line as line A. They ask you to find line A. The first thing that comes to your mind must be that line A is a line that touches x and y. You need to know which this line touches which plane. If it touches x and y in this case, then we simply can ignore z as equals to 0, because this line is totally not lifting, not flying out into the space, it's not doing that. So therefore z itself is just 0. Alright, so therefore we are left with 5x plus 2y is equals to 10. And if you want to set the equation in terms of y, then you just bring the 5x over there, you have 10 minus 5x divided by 2, and simply this is the equation of the line that is on this xy plane. So vice versa, if they want you to find let me say, let's say if this is another line, okay, let's say this is another line, this is line B, so this line B is on zx, then you simply take y is equals to 0, and then you sub in, you just write in terms of 5x plus z is equals to 10, and then in terms of z is equals to 10 minus 5x. So this is the line that describes line B. I hope you get what I mean. Okay, the last one is simply additional stuff that I feel that it might be fairly useful. The cross product that I shown you earlier just now is the ijk and then 3, 2, 1 some, and then 0, some values, maybe 5, 4, 6. Okay, this is one method of doing the cross product. Is a very important method. Nonetheless, I will also introduce you to the concept of the magnitude of, if you remember, the normal vector. Alright, so if it's sine theta is equals to 0, alright, if it's sine 90, then this means that cross product, this is cross product formula. If it's a cosine theta, then this is a dot product. Okay, so meaning that this thing comes, let's rewrite home. Okay, for the, I don't know what this color, beige color or whatever. If it's sine theta, this means it's cross product. If it's a cosine theta, in this case, it's a dot product. Okay, so either case, if it's 90 for dot product equals to 0, meaning cosine 90 is equals to 0, then sine 90 is equals to 1. Then this is just the concept of it lah. Okay, and therefore if it's a cross product, if you have to set it as equals to 0, meaning that the line itself, the vector AB, means that, let's say I have some vector AB, and then this is a normal vector N, right? This is AB. This normal vector, if it's 90, this is equals to 1. If it's parallel, that means that this normal vector now, okay, I switch it, rotate it to the right, ta-da, then it is somewhat, okay, I shouldn't transparent it, but it is somewhat parallel to your AB already. So if it's 0 degrees, or maybe I just rearrange this. If it's 0 degrees, meaning the normal vector is along the line of AB, then this means that it is equals to 0. But definitely normal vector shouldn't be along the line, but this is the concept of cross product. And the extension of that, you can extend it to A cross B. Never mind, I done A cross B. I'll just stop here, just to give you the concept of that. And we are done for the chapter of equation of plane and line. So I shall see you soon for other stuff that you might need. Bye bye.